Hello friends, welcome back to online school. And now let's talk about differentiation of inverse trigonometric functions. And then, so what are inverse trigonometric functions? So inverse trigonometric functions, these are trigonometric functions, or these are functions of this format. We can have our function like sine inverse of x, and then we can also have like tan inverse of x. So that's what we refer to as trigonometric functions. Then also cos inverse x, we can also have sec inverse x, like that. And then, so how do we differentiate these? Let me try to work out this one here, the first one, which is sine inverse of x. So we shall come here and say that let any, and like let y, and say that let y equal to sine inverse of x. And then, so from that we can see it is clear that when sine comes this other side, we shall have sine y. So we can take the sine this other side, and then we shall have sine y being equal to x. And then, so remember, we want to differentiate this. So we have changed its format, or we have simplified it to this. And then, so we have sine y equal to x. Then next we introduce the derivative symbol on both sides. Derivative with respect to x is sine y being equal to d by dx of x, like that. And then, so remember that y, it is a function in terms of x. So we shall have the derivative of sine y with respect to x. And then now here, remember that from differentiating from first principles, the section of differentiating from first principles, we proved that when you differentiate sine of any given variable like u, you get cos u. So here we have sine y, and then it means that when you differentiate sine y, we shall have cos y. This multiplied by dy dx, since we are differentiating a function y which is in terms of x, so you multiply it through by the derivative of y with respect to x. And then this is chain rule in simple terms. So this is chain rule, and this will equal to dx over dx, so which is a 1. And then, so we shall have cos y dy dx being equal to dx dx, or we can have dy dx being equal to, this is a 1 divided by cos y, like that. And then, so when we reach that step, we can use the trigonometric identity, which is cos squared y plus sine squared y being equal to 1. And then, hope you're all familiar with, or you've ever came across this. If at all you've never seen this, we shall look at it in trigonometry. And then, so from that we can make cos y the subject here, or cos squared y the subject. And then when we make cos squared y the subject, we shall have cos squared y being equal to 1 minus sine squared y. So to get cos y, we shall take the root on both sides, and here we shall have 1 minus sine squared y. Alright, and then when we reach that, so we shall modify our dy dx, and then dy dx, it will equal to 1 out of square root of 1 minus sine squared y. And then, so since our function, or our given question, it was in terms of x, we never had y anywhere. It is we who have let y to equal to sine inverse of x. So we can substitute. Remember, at this step here, we have sine y equal to x. And then, so where there is sine y, you can put x. So we shall have dy dx being equal to 1 over square root of 1 minus, since sine y is x, so we shall have x squared, like that. And then by reaching that step, that is our derivative function for the inverse trigonometric function of which is sine inverse x. And so I have some questions here, but then before, let's try to look at another example. Let's now try out the one of tan inverse of x, given a function y, given a function y, or differentiate y equal to tan inverse of x. So this is also an inverse trigonometric function. And then, so you follow the same steps. We have y equal to tan inverse of x. When tan get this side, we shall have tan y being equal to x. And then so when you we introduce the derivative symbol, so d by dx of tan y being equal to d by dx, the derivative of x on both sides. And then after that, when you differentiate tan of an angle, you will get sec squared of that very angle. So we shall have the derivative of tan y being sec squared y, but since we are differentiating a function y, so which is also a function of x, so we shall have this being multiplied by dy dx, and then this will equal to dx, this will be a 1. And then so upon reaching that step, we can divide through by sec squared y on both sides. So we shall have dy dx being equal to 1 over sec squared y. But then so we are also going to use another trigonometric identity, which states that 1 plus tan squared y equal to sec squared y. 1 plus tan squared y is equal to sec squared y. And then this could be x, it could be any other later. So we shall have sec squared y being equal to 1 plus tan squared y. So it implies that this one here, it is the same as 1 over 1 plus tan squared y. Then having that, remember we said here that tan y is equal to x. So we can have our dy dx, or we can substitute back for x, and then we shall have dy dx being equal to 1 out of 1 plus. Now since tan squared y is equal to x in this equation here, so we shall have 1 plus x squared. And then so this is the derivative function. This is the derivative function for tan inverse x. And then so in this tutorial here, you have looked at 2 examples, and then you can try out the one of cos inverse of x. You can try out the one for sec inverse of x. And then so let's have some few trial questions here. Let's have a few trial questions here. And then so we shall have trial questions. We shall have differentiate. We can have differentiate x sine inverse of x, or like a function y being equal to x sine inverse of x. And then the other one could be that y equal to cos inverse of x. All right. Now you'll try out those questions, and then if any question fails out, you can comment in the comment sections, or I'll make a video for all solutions of the trial questions. Thank you for watching. Don't forget to subscribe to my channel for more math content and physics.